that I'll be able to do that. Okay, it is, we are not allowed to place one key in a sensor node. There is a restriction on transversal designs. We must put at least two. I would like to show you how the transversal designs may be constructed, avoiding the mathematical complications. There is a pattern. There is a pattern here. You see, this column consists of A's only, then B, then C, D, E, and then I start from F, G, H, I, and J. I do a circular move here. I shift it by one. Again, I go like this: F, G, H, I, J. Again, I shift by one and move like this. In this way, I can complete this. This is a transversal design. There are algorithms available to construct these kind of transversal designs. And you can think, if I need to place 25 nodes, these are my 25 nodes, 25 sensor devices, and each of them contains two keys. It has got one specific property, connectivity property. It might be shown that any two nodes are connected with a certain fixed amount of probability. That might be shown. I'm not going into that details. I wanted to show you how this might be constructed. Probably I don't get time for that one. These three examples are transversal designs. Okay, I have described why transversal designs. Okay, what I achieved in this paper. I needed two things really: how large my area should be that I intend to cover. That is the specification of the problem, that is the user specifies, and the radius of the network that I denote it by rho. Don't mix this row with the other row. That is defined as the minimum of the communicating radius and the sensing radius of a sensor device. And the other parameter, this is very important, this is the robustness of the network. I denote it by RS. This is defined as the probability of having the area covered by a connected network of sensor devices, despite the random failure of S many sensor devices. A bit convoluted, but it makes sense. I'll tell you why. The first question that I tried to answer is, for any given node, what proportion of nodes in the vicinity share a common key for different sizes of the network. I derived some theoretical bounds for that. The exact mathematical formula is not tractable because of some finite field involvement here. It is not possible. But I can always write a program to find out what the exact answer is. I have done that. And the other one, how to design such a network if certain parameters are given. I also tried to answer that question. For this K is the number of keys in a given sensor node. This is the size of the network. I could write a program which calculates the corresponding value of the robustness. In other words, if the robustness is specified, I can find the value of K, number of keys that might be placed inside a sensor node. Usually the area is known. The area where the sensor network is deployed is known. We know the spacing of the grid. The radius of the network is also known. And the robustness, that is definitely a function of the number of keys in each node, the number of nodes, and also the size of the network. And finally the number of failing nodes is. But we cannot find any closed form mathematical formula for RS. That is a difficulty. Here we must resort to simulation. Otherwise, we probably cannot answer this question. In fact, I have constructed detailed design charts with the help of simulation for this problem. How I did that? I fixed a value of S, assuming that these many nodes are failing, and out of R square nodes, R by R square nodes, S nodes failed. So despite the failure of those nodes, I check if the network is still covered, and using depth first search, I check if the network is connected. I repeat this exercise several times to get an estimate of the robustness of the network, and I prepare detailed design charts in this way. Okay. This was intentional.
Could you wrap up now?
Yeah. I am done.
Yeah.
I am done. I want to show you the bad tables that I have constructed. These are available in my paper anyway. Okay, and finally, I had an example, a design example, where I have shown how to design a sensor network given this kind of parameters. When the size is given, when the robustness is also specified by the user at 90%, and it is also given that despite the failure of 1000 nodes, how can I design this network? And it might be seen from my tables that even with 2 keys per node, I can achieve this objective. Well, that is all about it, more or less. Thank you. Thanks a lot.